What's up, guys?
Welcome
So we
to
got
another episode of Eigenbros.
Mm-hmm,
Yes.
Mm-hmm. So we got a little bit of
Kind of off the cuff.
rocky start. I think.
Well, Terence thinks it's a rocky start, but
maybe it won't be because every time I watch the videos back, they're not nearly as.
You're
bad
like
as
it wasn't
I
that
thought.
bad. Yeah. I just think you got caught in the cringe part.
Yeah.
I'm telling you, it's better than it is.
I just don't like people watching me think on a video.
So yeah, this episode we kind of like delved into some questions that we had this week.
Yeah.
Some scientific questions.
A little review of me and Juan's leisure questions. you know.
About natural phenomena like
Yeah.
how does lightning form?
Yeah.
Or why does lightning form?
Mm-hmm.
Why does thunder happen?
Yeah. What's going on with fire?
What's going on with fire? Some of these questions
Some of
that we
these
just
deep
think
things.
about. Yeah, and then we kind of went into earthquakes, or we tried to explain other natural phenomena and like
how to cool a
how
planet.
much deeper it gets and how to cool a planet.
Yeah, we got
If
some
you
cool
could.
shit in here.
Yeah, it's got some interesting questions, but they were all like in the realm of what we typically ask ourselves day to day. Because I had somebody ask me like, "Do y'all really just think about physics all the time?" And I'm like, "I guess we do." But it's more innocuous than you think, right?
Yeah.
It's like all the deeper analytical stuff is reserved for like physics problems, I guess.
Yeah. I'm not scrolling equations with soap in the bathtub. It's not some beautiful mind stuff.
Yeah, exactly. It all starts with basic physics questions.
Right.
But yeah, I think that's it. So if you like what that sounds like, please stick around.
Yep. And first, of course, guys, make sure you like us real quick, subscribe, share, comment, and check us out, Eigenbros.com, Eigenbros on Twitter, Eigenbros on Instagram, Eigenbros2 on TikTok, and we'll see you guys in a bit.
3, 2, 1. Bam, 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 bam.
Classic intro.
Classic intro because this is another classic episode, I think. This is going to be a classic episode, and I'll tell you why. Because it's off the cuff, man. Nah, I'm just kidding. No, we had some interesting stuff that we talked about this week. Right?
Yeah?
Yeah, we did. I don't know if you knew this.
Oh, no. You're going to have to refresh me.
Because we were debating.
Juan's, putting me in the dark this episode.
I am,
today.
because I think he'll appreciate where I steer the conversation.
I love it.
This is...
Let's use that extrovert intuition.
Yeah. We got into a huge, little argument. Huge little argument. I know this contradictory.
Did
we? Yeah.
Okay.
We did. But it was
Soft line.
It's about a natural phenomena, though, that's occurring that most people don't really know about, or that science doesn't really know about.
Okay.
And that's why thunder
happens. Yeah. Well, not thunder specifically.
I mean lightning. Yeah.
So we know why thunder happens.
Yeah, we know why thunder happens, but lightning.
Well, actually, do we?
Yeah. It's the effect when like. Hold on.
Did we just create more problems now?
Let me put this. No, let me think about how to word this first of all. So we all know the phenomena of lightning. When it strikes the earth, right? It's this huge bolt. Well, we'll get to that maybe.
Yeah.
We should probably describe how what science
What
thinks,
was going on?
What science thinks what happens when lightning is formed.
Yeah.
Because that's like the main thing. I can probably answer the thunder one, but we need to first know how lightning is created.
Okay, yeah. So basically, this was something that was not very obvious to us. And I actually did a Twitter post on it a long time ago, but I don't even remember what I said. But my take was from what I researched, and I had to actually research this. I couldn't even bullshit it really in my brain because it was not so straightforward in my opinion. But
well, for the record though,
yeah,
science doesn't really have an answer for this.
Right.
There's like leading hypotheses.
But I think we should definitely have an answer for this in 2020. Yeah. This is long overdue, right?
Yeah,
we should know this. We should know this already. Yeah. So what my take is that one of the research I saw, they said that basically it has to do with ice rubbing against each other. So what happens is, this is me, I'm going to recreate the picture then. So this is what I think it is, based on what I've looked up and also based on my own piecing things together. So, of course, clouds are going to form from evaporation. So over time, you're going to have the clouds evaporating and those water, not clouds evaporating, but water evaporating from, like, let's say rivers and oceans.
Yeah.
That water rises up into the atmosphere, those H2O particles, and it's as a gas. and as it continues to rise in the atmosphere, things get colder, and as you should know, the pressure is lesser and lesser as molecules rise.
Yeah, and higher the altitude you go.
The higher the altitude. So if pressure is lower, we know PV equals nRT. P and T are on two sides of the equation. So as P goes up, T goes up, and as P goes down, T goes down. So as pressure goes down, the temperature goes down. So this means that the water droplets are going to start to freeze. Once those water droplets start freezing, they actually become too heavy to keep rising, and they actually start to link up. So it's like they become water. The water vapor starts to turn into a liquid now.
Yeah.
And then those liquids start to fall back down, and then that's how the cloud actually forms. So then you get this separation between heavy water molecules, or not heavy water, but of water molecules, and then the water vapor at the top. And then what I thought the next thing is for it to turn into ice is, since it's up in the atmosphere already, some of that stuff is not going to turn into water. It's just going to go. It's going to actually turn into ice because it's so cold. And then as it's turning to ice, this is where I kind of haven't filled in the gap. But there's going to be a jiggling between those ice molecules, and there's going to be a rubbing back and forth, and then that's going to somehow create the charge.
This is the classic.
The negative charge.
The classic question mark.
Yeah.
And then next
Profit?
Magic. Yeah, or profit.
Yeah.
It's basically, this is where the magic happens.
Yeah.
Is the rubbing and the static.
Yeah.
This is where I'm like,
I couldn't really justify that part. But it's getting close. I think it's getting close.
That's the leading hypothesis so far.
Yeah. It makes the most sense out of everything I've seen. But how those molecules are jiggling, why they're jiggling back and forth, and also why they gaining an electron, I don't know either. But we do know, but why are they gaining an electron either? Yeah, I don't know.
Well, I wouldn't say gaining, but it just like you overall, like, it becomes like it's the argument is that it creates static electricity, right? And you basically now create a negative. You almost polarize the cloud, right?
Well, you do polarize the cloud, right? From the sources we've seen, it says that the negative charges lay on the bottom of the cloud, and then the positive charges, and the positive charges are on the top of the cloud. But then if you have negative charges on the bottom of the cloud, you're either gaining an electron or you're gaining an electron somehow. So something is rubbing off an electron onto the water.
Or you're losing
a proton, but that's not going to happen.
What is it called? No. It's like that. Where you have a valence shell, right? Where you have something that you look for an electron. But I guess that's all the stuff that's up in the
you're
plus,
gaining.
right?
That means you're gaining an electron.
Yeah.
Because the only opposite to that is losing an electron.
Yeah.
Right, and you're not losing. If you're losing, an electron,
that's why I thought some kind of form of ionization might come in, like because you're.
Well, it is ionization, but it's a gaining of.
No, but I was thinking like because I remember I was arguing with you about this, saying that I think maybe at such a high altitude you have like. You have cosmic rays and other stuff coming into play.
Yeah, I'm not buying that.
But then I don't know. I mean, that's just. I was trying to cover all bases. Yeah, I was trying to cover all bases, but I don't think that'll explain it.
Yeah, I just don't think so because I think with cosmic rays and stuff, it just seems like
it could knock out a shell electron or something, and then you have then you can do that. But then I don't know.
Yeah, I just don't think it's right. I don't think it's right.
It just seems too.
I don't know enough about cosmic rays to completely dismiss it.
I know enough about clouds. I'm gonna be honest with you. No, but I also know water. I also know water absorbs a lot of radiation, so I don't think it's even. I don't think it's.
I don't think cosmic rays even interact with clouds that much either, because cosmic rays are like muons and shit, right? And muons are like heavy electrons, and I don't see them probably interacting that much. Maybe they are because they have charge though. They electromagnetic. They use the electromagnetic force, or they have.
Because I know they use water baths in those like detectors.
Yeah.
To slow down the particle or whatever.
Yeah.
But I don't think it interacts with water that to that level.
Well, I guess it does then, because if it can slow down water, it's interacting with it.
I know, but I'm saying like where you essentially ionize the water just by interacting with it? I don't know.
Not sure.
I don't think so.
Seems like a stretch, though.
That's my
Seems like a stretch.
That's why I was like kind of trying to cover all bases, but it's still perplexing to me that we haven't figured this out. I think the static electricity hypothesis is probably the most correct one, but I don't see how. Because you do get ice and you do get crystals, but I don't know if I've ever seen. Somebody needs to do this in the lab. Then somebody needs to see if ice crystals actually rub up against each other.
But I think I made that part up.
Oh, you did?
Yeah, that's what I was thinking would happen, right? Mm-hmm. Oh, or maybe I didn't make it up.
No, I don't think you did.
Now. Okay.
I think you read a resource about this.
Yeah, it makes the most sense to me.
Yeah.
It makes the most sense.
Because they say it generates static electricity, and then, so for the record, this potential difference, the positive ions up here and then the negative ions down here, you create this gradient.
Yeah.
Right, of charges, and so as we all know, that's characterized by a voltage, basically.
Yeah.
Yeah. So you can create
and then the rest is kind of easier, because then you can just say that why does lightning actually strike? Because that big cloud that's negatively charged at the bottom now polarizes the ground, because the ground is normally neutral, but now it's being positively polarized. So now there's potential difference between the cloud and the ground. And then all you need now is a way to complete the circuit.
Yeah, and this is true because victims, unfortunately, who have been struck by lightning, human beings who have unfortunately been struck by lightning report like hair standing up, right, or something like that. You kind of get this, like, their hair starts standing up. They start, like, it's like static. They start feeling it.
Well, they get polarized. They see the polarization happening in real time, because literally when you take static electricity to a balloon or something and you put it near your hair, it has the same exact effect, right? It starts to, especially people with really long hair, their hair actually starts to stick straight up.
Yeah.
And that's one of the major signs you're about to get struck by lightning.
And this is why in Dragon Ball Z, this is why they have their hair standing up, because they
right, and even their little
electricity
flame fume, their flames have the electricity come out of it. There you go. It all makes sense.
It all makes sense. The science of Dragon Ball Z. No, but
we should do that on a podcast. The science of Dragon Ball Z.
Yeah. No. But yeah, this is just incredibly. So anyway. You get lightning, and then you get thunder from it, right? You get thunder because the lightning comes down so fast that it creates I've heard that it creates a pressure difference.
This is actually tough too.
And what happens is this pressure difference is what you hear. You hear that clapping noise because it's like almost an instantaneous, like, ripping through the air. It's like it's like it's ripping through the air so fast, right? The speed of light. It's like this thing that just cuts through the atmosphere.
I'm trying to think about it though. So what's happening though?
The lightning is cutting. It's this ball of energy that's cutting through the atmosphere, displacing air. It's at the speed of light.
Why does it have to displace the air though?
What do you mean?
Why does lightning need to displace the air? It's light.
Oh,
I
guess. I guess not. I guess it's not
anything.
necessarily displacing it, but.
But
Well,
then
you create an
an
arc, right? But then you create an arc, so you charge the air around it.
Yeah, and arcs always have noise, it seems.
Yeah,
but it's weird because even arcs have noise in vacuum too. Like if you've seen those little Tesla coils, if you've seen those Tesla coils, oh, actually, maybe not. I'm not sure.
Think so.
Yeah, I can't say that for sure. Yeah, let me rescind that statement. I'm not entirely sure. I'm trying to think, why does a Tesla coil then even have a sound? Because you can play music with Tesla coils, right?
I think that's
what is the sound from?
I think that's just like heat, like a type of energy being dissipated sound. You know what I mean?
Yeah, but what does that mean? Damn it!
What does that mean?
This was maybe
what do you mean? What do you mean? What do you mean? What does that mean? I don't know what you mean. I don't know what your question is.
Because like just saying it's heat, it's sound dissipating is kind of a cop out to me. Because you can usually say what the sound is coming from, right? Like a sonic boom, for instance.
Yeah.
I can say the sound from that is coming from an accumulation of all of the air in front of the jet. So it's literally the jet is pushing so much air in front of it that eventually all of that air hits you at once.
Yeah.
So it's a giant punch. right? And I would think lightning is some kind of similar effect, where you just get a giant push of air, and it makes a big makes a big sound.
That's how I envisioned it. But now you're saying
but I just
not
don't
be like that.
Yeah, I'm just not convinced yet. I'd have to really think it out.
So when you see slow motion video of a lightning striking the earth,
Yeah.
is that not what you see? You kind of see like, because think about it, you're almost like you're taking plasma, you're heating up the air,
Mm-hmm.
and then it's causing this like cascade of like of particles that are just becoming
Ionized or something.
ionized. Yeah, and I think that energy is released. Then that would mean that the energy would be released as sound. Or just like, you know what I mean? It's an incredible amount of energy too, because you get obviously you get a lot of light, and then you get a bunch of sound.
Yeah.
It must be just an incredible amount of energy to generate. I don't know if, because I read somewhere that it was like the pressure difference or something, but I'm starting to think what would create. The only way you would create a pressure differential would be as if like the lightning is approximated like it's like just cutting through the air, but I don't know if it is. I'm starting to think it's not, because I'm seeing it more like the process of like a plasma, where it's like ionizing. It's like heating up the next, because the lightning's trying to find the path of least resistance, right?
What happens is the circuit gets completed. It's mostly like a circuit.
Yeah.
So if you imagine, I think what's happening is, from the polarization due to the cloud and the ground.
Yeah.
That polarization is also probably polarizing. The air or something, it's ionizing the air.
Yeah.
And then what's happening is,
because it's got to connect that.
Yeah, once those air particles just align, that vapor aligns with some path, that whole path then becomes connected, and now it's a complete circuit.
Yeah.
And I guess that's probably maybe from. Well, I got to think about that. I was trying to think is it from the impurities in the vapor, or is it strictly from the vapor in the air?
Oh, you're saying why does air become ionized to begin with?
Yeah. No, why does the circuit get complete? But then also a good question is, why does it become ionized to begin with?
Yeah, because you have moisture in the air. You can ionize water quite easily.
Yeah, but can you ionize it from polarization?
Yeah, for sure. Take a magnet.
How do you know?
Because if you have a strong enough magnet, you can form a tiny stream of water and actually push it with the magnet.
Yeah, but that's not ionizing it.
No, I know, but that's
just
how it
diamagnetic
reacts.
or paramagnetic.
Yeah, but that's to show. I guess what I'm saying is like an analogous situation with that, because like you can.
That's
you can
polarization,
easily,
though. You can think of that more analogously to polarization. Ionization is actually a stripping of an electron.
Okay, well then I would say that water molecules, right? They're more. The oxygen is the biggest atom shared in the molecule. Right. If you think about it, the oxygen is kind of like a Mickey Mouse diagram. It's the two hydrogens up top as the ears, and then the oxygen is like the Mickey Mouse head. So the idea is that oxygen is electronegative. One of the most the farther up you get on the upper right quadrant of the periodic table, the more electronegative it becomes. Meaning, like the more likely you are to strip elements of their electrons, or like their valence electrons at least. So with oxygen, going upper right. So everything in the oxygen
towards like the helium.
Towards like.
Is that true? Because then I thought.
No, I'm looking at fluorine and oxygen.
Yeah, I thought those don't want to give up electrons.
No, those steal electrons from you.
Oh yeah. Okay.
Yeah. They're more likely to strip one.
Right.
Strip a valence electron. So like with oxygen. I imagine it's a similar case. It's a pretty electronegative element. So that would mean that, like, if you place it in water, right? The only reason why you get such a, I guess, the state of matter of being a liquid is because the way the water molecules bond to each other, it's like the oxygen being so electronegative that it kind of like shares, it takes some of the, how would you say? It takes some of the hydrogen, it connects to the other hydrogen molecules in its shared vicinity. Do you see what I'm saying? It's like you can imagine a Mickey Mouse. So it's like,
which is part of why I think, why the water comes back down in the cloud.
What do you mean?
Because you're saying that it has a tendency to share an electron.
Yeah.
Yeah, so when there's water molecules next to each other, that's why water's got this crazy surface tension, right? And liquids, I guess, in general, because they have that, they're like on the verge of becoming solids, but they're bound when they get close enough to each other because they want to share that electron.
Yeah, what did they call this? It's like there's different types of bonding, but I guess there are technical names for it.
There's like covalent bonds and ionic bonds.
Those are stronger. Ionic bonds, I think, are weaker. I want to say, yeah, because
covalent
covalent bonds, I think they actually have to share their valence electrons. But I think ionic bonds are more weak because it's kind of like water. Like you're slightly ionizing the molecule so that you achieve some type of bonding. And I think this is why I think you can ionize water so easily, because it's got that big old Mickey Mouse head where it's like you can make it bulge out or something. There's more of a surface area there that lends to sharing or to pulling. I'm trying to envision it in a way that makes sense. Pulling, no, not pulling. What's the word? Yeah, just sharing that electron. It makes it easier to not strip it away, because it's not going to do that. But yeah, I hope that makes sense.
Maybe. I feel like this is too out of a topic for this podcast.
No. Maybe not. The thing is, like, this is just like level 1 chemistry. I just think that
it's not simple.
It's not simple, but.
It's not simple.
But I think you can ionize the moisture in the atmosphere pretty easily, and I think, I think this is pretty much. I don't think it's that much of a problem explaining that. Because you were saying, what was the other? I forgot the other question. That's why I'm like, I don't think that's a problem.
What's the other question?
Yeah, what was the other question you had? Because you had two problems there.
With the lightning.
Yeah. Because you were like, I have an issue with the how do you ionize the atmosphere, and then what is the atmosphere like?
Yeah, how do you ionize, and then also how do you or even is ionization?
What do you mean?
There's just a lot of steps of not certainty in this system.
I mean, it's a lot more complex than I gave it credit for.
We made an attempt though, but
I think
resting on my laurels here, like I think I can, because I think I have enough chemistry knowledge or whatever to kind of say, like, not definitively, but that's a pretty accurate description, I think, of lightning. And yeah, you don't think so? How not?
I just don't feel it's satisfying to me. Usually I feel like if I can explain something very simply, then I'm satisfied, but with lightning, how it
but this is like its first iteration
very,
off the cuff, just coming up with something.
Well, yeah, I guess so, but
this is not the most refined lightning hypothesis. But
that's an understatement.
But these are just ideas that I'm throwing out there. I'm just like, it could be this. I suspected it's that, given my base of knowledge. But yeah, it's speculation until more data is collected, right? So
it's a tough topic, though.
It's a tough topic, apparently. So if you're a researcher out there who studies climatology, what would you call it? What branch of
meteorology? Maybe
meteorology? Yeah, meteorology.
We've got a meteorology school. There's a
Oh
meteorology
yeah. A big school, actually.
Yeah.
But yeah. Anyway, that was not as trivial as we thought it would be.
No.
The lightning, the topic of lightning, lightning round.
And then we also tried to tackle fire, and that was also bad. But let's not do that now, because I don't want to look even more stupid.
What do you mean, fire?
Yeah, because remember we were trying to figure out, like, what even is fire? How can we describe it?
What do you mean, like with chemistry?
No, because I was. What was the thing? We were talking about the gravity in fire. How fire only has a shape in a gravitational field.
Oh, this is an interesting point.
Yeah.
Yeah.
Because when you're fire in space, it's just a ball. It's not. Doesn't have a shape. It's like a ball, just like.
But this helped us answer the lightning question too a little bit.
Did it?
Yeah, a little bit.
Oh, with the density.
Yeah.
Oh, yeah. But then we were still very lacking in its description.
Well, because fire apparently, like if you light up a fire, you have the characteristic like little teardrop formation shape, and
like a candle's a perfect
candle's a perfect example of this. Yeah, or a matchstick or something, and you will see. The question is, why does it create a teardrop shape? You know.
Yeah.
But as a physicist, you kind of have this intuition, like, oh, you know, you see the same thing with water droplets, right? Like you almost see this other thing occurring as well. So it gives you a sense. Well, yeah.
It's like Aristotelian. You know, the everything is composed of elements and of water and fire and ice.
Yeah, but you kind of do get this sense of like, oh, water and fire look kind of the same, but that's only because gravity, right?
Yeah. Like water, gravity as well, right?
Yeah, so
same teardrop.
In parallel, water and gravity, you get a spherical. It can,
but the descriptions are different, though. I think
for sure,
because the reason fire has a teardrop shape is because of the density of air, you know, and I think it has to do with the ashes being less dense once they've been burnt, wanting to rise up, and then the water, and then the fire is basically that smoke. Or shoot,
the smoke? What do you mean?
Not the smoke, but
like
the fire is like tiny bits of whatever is burning, rising up.
Yeah.
But
so all the heavier stuff is at the bottom, right?
Well, all the heavier stuff, not heavier stuff, but all the stuff has not been burnt off is at the bottom. But then once it's been burnt up more, it rises up.
Gotcha. Yeah. So the convection almost as well too has to do with it. Right? Because the heat rises and stuff, or no?
Not sure about that. Because I wouldn't include that.
You wouldn't include that principle? No. I would, just because it's like.
I don't think it's relevant.
No.
No.
You think it has more to do with gravity then?
Damn, this is not a good podcast.
You don't think so? I think it's good, bro.
It's too much thinking, man. This is like truly testing our.
You're seeing the machinations
right now.
You're seeing the machinations of the gears grinding.
Yeah.
No, but I just think these are interesting questions. But no, I think.
Me too. But we got to be thinking
pondering,
for sure. We got to be pondering a lot.
True.
And like actually really thinking about these things because these are just really deep questions, right? That's why I typically like to stick on easy stuff.
I don't know, dude. I feel like a physicist.
At least research stuff.
I feel like I've asked not every time, but have you ever looked at a professor? There was a professor that I know that could explain everything in the room. Mm-hmm. Like they sat in a room and they explained.
Yeah, because he probably thought about everything already.
Yeah, but that's kind of the beautiful thing.
Yeah.
To me, I looked up to him.
I haven't thought about shit. If I actually thought about shit, then I would actually be able to explain it. But I haven't thought enough.
He was able to explain everything happening in the room. Like I asked him about the light. And he'd be like, yeah, that comes from this and that and this and that and blah, 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 blah. He could literally explain everything. And I looked at him as kind of like as a sage, you know. But
that's how you got to get, ideally.
But that's the level that you want to get to, like, of, at least for me, monk levels of understanding.
Yes.
Where it's like, I can explain the heavens. You know, I can explain the, right. like, you know, one of the most fun examples that they give us in our undergrad textbooks is what is it called? The scattering effect that gives sunsets their beauty. Do you remember this?
No.
This is from Griffiths, I think.
You mean like their color?
Yeah.
Oh yeah, I already know how to explain that one.
Yeah.
It's because it's just traveling through more atmosphere. As the sun goes down, the angle now is going through more and more atmosphere, and then as that happens, you get more of a redshift.
More scattering.
Or more of a scattering towards the red. Yeah. So the wavelengths, the light gets elongated. The wavelengths do.
See, that's beauty of physics right there. You get to see the equation in your mind.
I'm not seeing any equations.
Yeah. You're just like, I'm seeing the principle.
Yeah, I'm just trying to see the concept.
Yeah.
But I did a Twitter post on that one, so I remember.
Yeah. But that's a classic like problem that's answered by like electricity and magnetism, I guess.
Yeah.
But yeah, there's a lot of those. Like, do you think you could answer like half of the effects? Like, say you were sitting in the office, and like, could you think and you're the only physicist in the room, do you think you could answer how most of the things work in that room?
Probably to some level.
Yeah.
Not to a level I would still be happy with,
Yeah.
but definitely to a level I could give a good shot at a lot of, pretty much most everything, I think.
Mm-hmm. I
But
feel
then
the same
for
way.
me, I just don't feel satisfied until I really, like even the lightning stuff, I feel like I can give a good shot, but there's holes in my knowledge.
Yeah, because I think more information needs to be collected, right? With that
Yeah.
lightning thing.
And more thinking needs to be done.
Yeah, but I think it's hard to do first principle stuff like that.
Yeah.
When you with especially with real measurable things. Like you need to have some.
Not always. No, I don't
I think you
so.
need some totem poles of information.
You do, but I think we have them all.
Really?
Yeah.
I don't. I think we need to collect more
I
information.
think we do.
Maybe
I
I
think
don't
we
have.
do.
Maybe I need to read scientific papers on this.
I think it also is harder when you have to build the intuition for recreating things as well.
Mm-hmm.
And I think that's been something I've thought about for so long. I have good intuition for rebuilding things from a theory perspective.
Yeah. Yeah, I've seen you do it. It's pretty cool.
Yeah, but I think there's certain things that are at the edge of my limit there. And like lightning, fire, those are like the edge of my ability, I think.
Earthquakes, can you explain earthquakes?
Earthquakes. So of course it's just the tectonic plate shifting, right?
Oh, here we go. We got Terence trying to tackle earthquakes.
Let's think about it.
I'm telling you, it's a lot less complicated. I mean, it's a lot more complicated than you think.
Probably. I have to think
Yeah,
why
100%
though.
is.
So earthquakes.
I sat in a whole class of geology.
Oh, really?
Yeah, so I know the answer.
So let me think about this though. So
yeah, there is a shifting of tectonic plates, but why, right?
yeah, I don't even know what the hell a tectonic plate is either. So I'm just like I'm
It's-
starting
it's
with
a
my
pla-
Wikipedia knowledge.
It's a plate. It's a plate of
A
Earth,
plate of mass.
of massive rock. Yeah, yeah.
But why does that shift? So let me think. I guess I would imagine that the Earth Earth is like a bunch of layers, right?
Yes.
I would imagine it has something to do with the spinning of the Earth.
Okay.
Is this
pretty
true?
Good. Pretty good. Okay.
Okay. So then the spinning of the Earth.
Well, spinning in what sense?
So the Earth just
Rotating?
Yeah, the Earth is rotating in space, right?
That could be a component. Yeah.
You gotta check me because I don't know if this is even right.
Okay.
I'm starting somewhere.
I think it does contribute, but not as big as you'd think.
Okay, so it's not the significant part of it.
I don't think so.
Okay, so then maybe my next guess would be it has to do with the pull of other planets. Does it have anything to do with pull of the moon on us or the pull of?
That is a factor. Yeah.
Okay.
That contributes.
But it's a small.
Probably bigger than the spinning.
Okay. So then that's still not the major reason. Okay, so then let me think. The major reason would be what? What would it be? So land masses like continents, I believe, are still like. Are those actually bounded on the Earth, or are they like floating? I think they're bounded on the Earth.
Ooh.
Correct? They're floating. Oh, because Pangea was a thing at one point, right? And they broke off.
But they
I can't
broke off
believe they just
because-
sit in this place, though. That's so crazy. You would think there'd be more drift over time, but they're just so heavy that they don't drift. So they're floating.
Well, weight is a component, but I think there's more happening under the Earth.
Oh,
than you
there's more
think.
happening. So they're floating, but they're only in place because they're actually rubbing against
What are they floating on, though?
on water.
No.
They're floating on ice.
No.
What are they floating on?
Magma, man.
Oh, they are.
Yeah. It's like the Earth. Like if you think about the Earth's core, right?
Yeah.
It's like a slightly semi-metallic, not semi-metallic. It's like a.
But wait a minute. If
It's like solid liquid kind of core.
But if we're talking about a landmass, like let's say the United States, that's not floating on the water in
No.
the ocean.
No.
So it just goes so far deep, but it actually touches
connected,
the
yeah.
magma.
Like at some point it's connected to that bath, the core.
So
of
it
the
is.
Earth.
It's and then I would consider it like it is bound to the Earth. Then though,
It is, but
right?
yeah. But it has to do with the inner turmoil of the Earth's core, shifting the core. Like
See, there's some real shit I gotta really
It's
understand about
it's
planets that I'm
insane.
not familiar with
it's
at
insane,
all.
actually. What actually
Okay.
happens is like you create this all the it's interesting because like one thing that made me kind of surprised about when I was sitting in this class was the professor saying that sometimes solar flares will cause earthquakes. A solar flare can trigger an earthquake, and that's apparently because
of the magnetism, right? Because a solar flare has a magnetic field, and if you're saying it's on magma, then that means that magma is moving, right?
Yep.
It's made of iron.
Yep.
And that magnetic field then gets triggered, and then it's going to move the planet, or it's going to move the landmass as well.
Yep.
Interesting.
It blew my mind.
That's
I was
crazy.
like, what? And can you imagine there's people thinking like, just people finding that out, just finding that correlation, like, oh, we measure a solar flare and then EKGs or whatever they're called. I don't know.
Not EKGs, that's for the heart.
The Earth's heart is no, but you get these seismographs or whatever they're called.
That's it.
They just start going off the charts. Yeah, it's crazy. Like, but yeah, I think that's the biggest component of what determines earthquakes, like these things that are happening underneath. And the crazy thing is we don't even really know because we can't penetrate that deeply.
Right. Shit gets kind of unknown when you start to go down the magma territory. Because even I remember they were a little bit baffled by the shifting of the Earth's magnetic poles. Recently. Well,
they're
recent-ish.
That's why are they why do I read these pieces all the time?
Yeah.
Like
I've seen the shifting of the magnetic pole problem so much in my life, and people are always baffled by it.
I'm just like, okay, but I always skip it, kind of like, okay.
They'll figure it out.
Yeah, I mean, because it's like they always it's not going to do anything.
Yeah.
But they're still baffled by why it's shifting in the way it shifts. And I'm also chalking it up to just the fact that it is the whole reason we have a magnetic field is because of that liquid magma, right? And then I'm just like, it's because the magma is all fucked up doing weird turbulent shit. So it's like
we'll never know.
Yeah, it's like any turbulent systems are always kind of just crazy.
Yeah.
So
yeah,
imagine if we had better computational models of what was going on, then we would have some answers. But it's
it makes me think. It makes me think like, okay, if you turn off this internal engine of the Earth, would that like essentially, like if the Earth had a solid core, then it would be dead,
I don't think that'd be good. I think we'd die. Yeah, because then the thing is, we're also being shielded by cosmic rays all the time from the magnetic field, right? Of course, some of them make it through, but I think if we didn't have the atmosphere or the magnetic field generated from that liquid core, I think we would be done. Like that's one of the things that they talk about as a potential problem with us with Mars. I think.
Yeah.
Because Mars, don't quote me. I think Mars has a solid core, a non-liquid. Yeah. So it has no no magnetic field.
Yeah.
And I think that's a problem because then the radiation is going to be intense. So we're going to have to, if you have a Mars colony, you'll have to have some ways to blocking out radiation.
Or you'll have to get used to your cousin Larry having a sixth toe and stuff.
Yeah.
Or glow in the dark while you're eating.
Yeah. No, dude.
Reminds you of those ghouls in Fallout. You ever play Fallout?
Yeah.
Hilarious.
Yeah. No, the other thing I think, because there was a bunch of interesting questions we had. Like, what was the other one? Because I asked you, how would you make a planet cold, or could you make a planet?
Oh yeah, we did.
Yeah. We're like,
forget about that. Yeah.
Like how? And this is a question actually.
Damn it, Juan! Why are you gonna bring all the hard shit?
Because man, these are interesting questions. I'm letting people know.
But we look stupid on the podcast because we're just pondering the whole time.
We're letting people into
the inner workings of our minds.
Yeah.
Well, here you go, folks.
The psychosis.
We're really dumb.
This is a psychosis, I think. No, but this is like, this is the inner machinations of how we figure things out sometimes, right?
Yeah.
Just, but no, I posed it as an innocent question, right? It was kind of a sci-fi-ish question. How could you make a planet? It is a sci-fi. This question has no bars in reality, I think. Right?
Because, maybe, but the thing is, if we start to become like a type 1 or type 2 civilization, we might need to know these things, right?
Yeah, they're going to go back in the annals of history.
Yeah, it'll be like Juan Terence podcast, the Eigenbros podcast, episode 78.
Yeah, they figured it out. Then they're going to name the planet after.
Yeah.
No, but yeah, I was like, how could you cool a planet? Because I think it's easier to heat a planet up than it is to cool a planet.
Yeah.
right?
Yeah, and the first thought that came to my mind was using the laws of thermodynamics, because we know that any two systems and any two systems that are conjoined are going to have to balance to thermal equilibrium. So my imagination was if you could just make a gigantic ball of ice or something, or
a replica of the planet.
Yeah, a gigantic replica of the planet that just was a giant thermal conductor. Is just really cooled down. You can just link it up to the planet and then have all that heat transfer, and then you'll at least have the planet shrink its. Yeah, you'll be able to cool it down at some level.
Yeah,
it'll all balance the equilibrium, so you'll get half of whatever between the two temperatures that the faux planet and then the real planet are.
Yeah. But that definitely would take.
But that's just like
type 3 civilization.
Where you're taking an entire
where you're literally making an entire planet.
At that point, if you make a copy of it, just
just make a new planet.
Yeah.
Like the amount of resources that takes is probably just not worth it.
Yeah. But
unless it's like they're trying to preserve after Earth's been long through its course of burning up into turning into Venus, then we just want to preserve Earth and bring it back to its old state.
Well, yeah, because we were thinking, how could you cool Venus down? Because people are trying to occupy or trying to like make Mars a planet, right?
Yeah,
Mars is habitable in the sense that
we could walk there and be okay.
Yeah, we exactly. We can
temperature wise,
right? Because it's the fourth rock from the sun, right? Venus is the second.
Yeah, Venus is the second.
Mercury's the first. Closest,
yeah.
So yeah, the that by its own makes it more habitable than Venus. But I thought Venus is bigger.
Yeah,
so that's why I thought I was like, then that means that it's probably better. But you were saying it's incredibly hot.
Such a Texan.
What did I say?
You said Venus is bigger, so it's probably better.
Oh yeah.
That's that Texas coming out.
Yeah, it is. but yeah, it's probably better. But the thing is, you were saying it's hotter too.
Yeah, much hotter.
Incredibly hot.
It's got a sense of deja vu
by proximity from the sun. You're saying?
I believe that's my guess. That's where my guess came in. I'm not sure if Venus is hot by some other means, but my guess was because the sun. Yeah. Because like the Earth is heating up, right, because of global warming, and we're stripping away our layers of atmosphere.
Yeah,
and the reason that's bad is because heat is actually being trapped. Oh no, not stripping away layers. I'm sorry. It's actually because we're putting a blanket over it, and the CO2 is trapping the heat. Okay, so that's different. Sorry, I'm trying to reason through.
Sort through.
This is why. I'm thinking through right now, so I might say dumb things first. So yeah, that's not something to do it.
We're thinking out loud.
Yeah, so maybe that could be related to Venus. Maybe Venus has some crazy blanket of gas that's trapping in heat.
That's true.
I don't know.
Very true.
So
I
can't.
Saturn, right? So those big giants, those big gaseous giants, are also in that same camp.
I'm not sure how hot they are.
I think they're incredibly hot.
Okay.
Yeah.
Those are kind of really mysterious to me. I don't really know that much about planets and stuff because we're not astronomers. And astronomy is almost in physics is like a completely separate field.
Pretty much.
Yeah. And I mean, a lot of physics is like there's the big areas of physics is condensed matter, nuclear physics,
particle physics,
which is a little bit closer to nuclear.
Yeah.
What else is there? That's
true. It is a specialty of nuclear. I didn't even think about that. But condensed matter, nuclear.
That's it, right?
No, bro.
Am I tripping out?
Astrophysics.
And then astrophysics. But those are the only ones, right?
3?
Yeah.
There's got to be more.
I felt like there was. I thought there was at least 4.
Because then I was thinking, particle physics, I guess, is a subset of nuclear physics.
Yeah. Those are the big major branches, right? Because
optical.
Yeah, I guess so. It's now a thing.
Oh,
now,
maybe that
right?
is.
No, you're right.
You could put that under condensed matter.
Yeah. But it's kind of a thing now because it's, people like focus solely on optics, but then it's like nanoplasmonics and shit like that, which is related to.
So maybe it is connected. Maybe those are the 3 main.
Yeah, I guess
subjects. Nah, man.
I know it seemed like more, right?
But it does seem like more. But then I'm thinking, a lot of them are subsets of these 3.
Yeah.
Anyway, so where does astronomy fit? Is it fit under astrophysics?
Yeah.
Oh, okay.
I put those 2 in the same.
Gotcha.
Astronomy is just the layman way to say it, and then astrophysics is the enlightened man's way.
Yeah.
But yeah, I think planets are interesting, but it's definitely out of our wheelhouse, right?
Yeah.
And Venus is hot by some means that I'm unfamiliar with.
Which makes me think maybe the way to go is creating an artificial dynamo.
Ooh,
If you want to create a
Like
planet.
a sun?
Yeah.
A dynamo is like a... Can you explain what a dynamo is?
Like kind of like the Earth's core, where it's like just a magnetic kind of thing.
It's a magnetic...
Natural magnetic process, or
but are you
process
trying to
that creates
create
a magnetic field that protects the Earth.
But are you saying
Somewhere.
that for Mars?
Or any planet that we want to
Sounds
create
hard as
a
fuck,
habitable
bro.
planet. I know it is.
Sounds like something that'd be extremely hard. Think about the boring company with Elon right now and
Yeah,
how
yeah.
long it takes to bore holes.
Yeah.
How would you'd have to somehow bore a hole in the center and then make
No, because you're
liquefied
exploiting
magma.
because what you're doing with gravity is, or in the Earth situation, it's exploiting gravity in the sense that, we sit in this Goldilocks zone of like just the right amount of gravitational force relative to the sun, right?
Okay.
And we also are able to have enough distance from the sun that it is hospitable to life, right?
Yeah. But also
And-
you could kind of think you could also chalk it up to just we just were born on this planet, so we've grown into the traits that are the most habitable for our particular form of life.
That's true.
We only have a sample size of one
One.
planet, right? So we don't really know all of the possible ways life can exist.
Yeah, because the
elsewhere.
argument is that we're carbon based, right?
Yeah.
There could
And some
be-
people believe that you can have life that might emerge in like methane, because we always look at water as the source that you need water. What are the constituents? You need water. You need an atmosphere or something.
Yeah.
And you
Carbon,
need
dude.
oxygen
No, just
or something. I don't know.
Yeah, you need oxygen.
Um,
Oxygen, hydrogen, lightning. No, that's actually how, because there's a subfield too, astrobiology.
yeah.
That looks at some, I guess, configurations of how you would get life.
Right. With the
conditions
whole
for life.
abiogenesis.
Yeah.
And I know you were kind of a little bit being tongue in cheek with the lightning, but I know you're also
I was
being serious
I was
because
being
like that's
serious,
one
yeah.
of the theories, right?
It
It's
is.
somehow the lightning jump started.
Yeah, do you know about this? Like quite a bit?
I think, well, not a bit. I remember researching it when I was in my whole conspiracy phase.
Oh, really?
Oh, yeah.
It became big for me when I started undergrad because I was a biology major at the time. And the lure of physics was interesting, but I wasn't great at math at the time. But
Okay.
so I looked at it as kind of like, oh, this is cool. Because for me, I studied biology because of evolutionary biology. It wasn't that was like the subset that I was getting into, but
Yeah.
that was intriguing
Mm.
because you're trying to
Yeah.
answer the question of
Like, how did life even begin?
yeah.
Right.
But you're saying you came at it from a conspiracy point of view.
Well, it just was one of these things where I got caught up, because I was so interested in just figuring out what it all means.
Oh, gotcha.
I somehow landed on a biogenesis, and sometimes when you're doing conspiracy bullshit, you land on things that are actually
Have some legitimacy
Yeah, have
to
some
them.
legitimacy. Yeah.
Yeah, I looked at some of the studies. I think NASA was heavily investigating it, right? They were.
I'm not sure.
Yeah, because
Not
I
familiar.
knew somebody who actually went to go work for a summer internship with NASA studying this.
Mm.
I think they went to Caltech, although I don't know if they made it out alive.
Right.
But yeah, the thing is like.
Caltech, oof.
Yeah, I know that just made me think. I'm like,
Brutal.
man, I hope he made it out alive.
Yeah.
Really, sincerely, I'm just like,
Jesus.
just must have been brutal. But yeah, the abiogenesis thing, that's kind of the idea, right? You create this like primordial soup of chemicals, and in a closed environment. And I remember seeing this diagram of how would you say? It looks like a what are those balls of lightning that they make?
Ball lightning?
No, those balls of lightning that they make in the like you put your finger on it and like,
Oh, the Van der Graaf.
yeah. So it kind of looked like a Van der Graaf ball thing, and you could generate electricity. And the idea is that like when the lightning was enough energy to kind of like make some of these chemical reactions happen and start creating life, essentially.
Yeah.
Or you had enough of them that created configurations where lowered the overall energy of the system. And so,
do you know how seriously that's taken today?
I haven't seen it gain that much traction since then, since the early 2010s.
I wonder why.
I imagine because you would need larger scale studies. I think they didn't really show that you would have life. It did show that electricity can create certain types of reactions that need energy, right?
I guess maybe what might be convincing is if it actually produce like the proteins or something.
Yeah, or a baby.
Or baby.
Baby comes out, wee, wee, just out of the bath, just crawling. Just
Makes me think of that game.
That crazy ass Hideo Kojima game. Have you seen?
No, what game is this?
It's got like babies in a fucking test tube or in a tube and whatnot, and the guy's like, I forget what it's called. It's called
So what is it?
I don't know. It's like
it's Hideo Kojima. So
yeah, exactly. I can't even explain it because it's so crazy. It's all over the place.
Yeah, Hideo Kojima is like a classic example of a guy who's married to his craft, but he's not afraid to go somewhere weird.
True. That's
Respect.
Yeah.
Yeah, but I imagine the baby coming out of the water, like sort of like Terminator machine style, like just. No, but that would be cool though. I think you're right. I think they would need to show like that the proteins that you would get proteins of life like DNA, and I think maybe they I don't know. I'm not an astrobiologist, but I read one or two papers back then, and I was like, oh, this seems very promising. But I mean, if it was this promising, there would have been more information out now. I think
maybe
kind of
so.
Our intuition is probably,
or maybe it's a hard problem. I don't even know because this is so out of my wheelhouse. I mean, literally the only time I ever researched it was, back in like 2011 or something.
Yeah, true. Crazy.
Yeah.
But yeah, so that was your way to cool this planet, huh?
Yeah, just thinking of thermodynamics.
Yeah, because for me,
cold body touches a hot body,
Yeah.
they become warm bodies.
Yeah, because I was
Simple as that.
thinking space needles or something. Like
Yeah,
acupuncture.
Yeah, I forget.
Draw
I forget
heat
what was
away
going on.
from it. But then I was
This
like,
is similar though, because it's like you got to connect it somehow.
yeah, you do. But then,
Oh, but you were thinking like stick the planet with needles. Yeah, I didn't know what you were saying. 'Cause
Yeah.
we were getting complicated with that, right?
yeah.
Like turning it into a radio antenna. And
Yeah, it was getting
too
way
much.
It was too
It's
much.
too difficult.
It was too because then you would need to create thousands of satellites to like even surround the planet with this. And I don't think I think
And
the
then
analogy.
also you have to be radiating enough.
No,
I don't even know how
you
you
had the best argument against it though.
I forget what it was.
Because you said the needle would just find equilibrium and then you wouldn't even transfer heat anymore into space, or whatever. Or the crux of the argument was that I thought you could dissipate heat into space, but your argument was that it's not. It doesn't seem possible.
Yeah, I don't think you're going to
Yeah.
dissipate it into space like that.
Yeah. And I
And
was
if you
like,
do,
I
it's
think
not
you're
going to
right.
be fast enough.
Yeah, I think you're right about that. But these are the questions. So how would you, for those of you folks listening,
How would you cool a planet?
how would you cool a planet? I want to know because this is
Giant fire hose.
But I mean, the quickest way I think with the whole earthquake thing is if you somehow stopped that internal process, I guess.
Well, that's not going to cool the planet down.
Yeah, it's going to kill your planet essentially, right?
it'll kill it. It won't cool it. That wasn't the
You don't think
That
so?
wasn't the question. How do you kill your planet?
I mean, in some ways, yeah, I think you would cool the planet, right? You would kill the planet.
No, you won't cool it. Why would it cool it?
I guess maybe not.
Because the only thing that
Well, you're removing all the heat, right? You're stopping this internal.
no. Why do you say that's removing the heat?
Because your whole magma system, bro, if it becomes solid.
Yeah, but we don't feel that heat. If we felt
we
magma,
don't.
we'd be fucked.
Of course not.
The only heat we're feeling, hopefully, is the sun, man. I hope we're
know,
not
but I'm
feeling
saying
no
like if
magma.
you look at the overall energy in the system, the idea is that if you lower the energy,
Yeah.
a component of that energy is going to be heat, right? Unless the heat just transfers into some other
That's
thing.
probably that doesn't even really hit us.
All right.
Right. I guess you can you'll maybe reduce the overall heat of the planet just from stopping the magma, but it's not relevant for us really.
Yeah. Well, that's going to be the next Marvel superhero villain. The guy who
The guy who stops. I think Magneto. Maybe that's Magneto's final form.
Oh, that'd be so cool. But that's X-Men. But yeah, that would be.
Yeah,
cool.
but he should be able to in theory, right?
because it's made of liquid molten iron.
There you go, X-Men. If you really want to make Magneto into like a what's his name, Infinity Gauntlet
Pyro.
guy.
Oh, Thanos.
Thanos. If you want to make a Thanos type like large scale event,
I've always felt that Magneto was way more powerful than.
you literally control.
You can control a lot of shit as Magneto.
Yeah.
There's a lot of iron in everything.
Mm-hmm.
You
could even
water has
You
a
can
ton
control
of impurities
people
as well.
too. If you think about it.
Yeah.
Because everybody has like
Iron in their blood.
Yeah.
Yeah.
I think they might have done something like
They
that.
exploited that.
Maybe, I'm not sure.
Like he just like kills people instantly just by like
I think he did
creating
maybe.
aneurysms in their brains.
Yeah.
'Cause you could literally do that.
Yeah,
Like,
Magneto is way more powerful than
he might be the
he gets
strongest.
the rap.
He might be the like in well.
Well,
I guess strong is a subjective.
because
thing.
Jean Grey can literally manipulate matter, so that's
You automatically win on that front.
it's the same thing. Only it's just
Yeah.
it's all matter instead of just iron. But iron is pretty damn effective.
Yeah, but Magneto could literally just make you go blind. Imagine him deflecting light, like so you don't see anything.
How?
Because he's supposed to control electricity and magnetism, right?
No, I think he only controls metal.
Oh,
So
okay.
like he only can control like
Ferro-
iron, metal, and
ferromagnetic stuff.
I think maybe does
I
he
thought he
control all
contr-
metal or only ferromagnetic? I think he controls all metal.
all metal.
Yeah,
Okay.
anything metal. That's a good chunk of the periodic table.
That is a good choice.
That's pretty damn good skill.
And if he knew physics, he would take it to another
Yeah,
level.
exactly.
Maybe that's his limitation. He didn't study enough physics in
Yeah.
college.
In the X-Men School of Mutants.
Dude.
Yeah,
Yeah,
'cause that's a damn good ability.
Yeah, because if you had a guy who controlled literally electricity and magnetism, yeah,
Oof.
you'd be.
That's a wrap.
Literally everything's made of. Like all humans have electrical signals in their brains. You just stop the electricity in their brains and
Yeah.
you kill everyone instantly.
Yeah. Although they should make a parody of him, not
Magneto?
like not in the comical sense. I mean it like in the like symmetry kind of thing. Like if he's a magnet.
Oh, a parody, like
yeah.
a PARITY.
Yeah.
Oh,
Like if he's magnetism, then there should be electricity kind of version.
well, he's
Storm.
he's Magneto, but he controls metal. I think.
Yeah, but is Storm supposed to like I'm saying? What's the electrical analog?
Yeah, I guess Storm would be.
Storm.
If she's the electricity. But I think Storm's a little bit different because I don't know if she can control electricity. She can only control weather.
Oh, true.
But she can shoot like electricity out of her hands or something just for the added, cool lightning effect. But Storm's pretty good. Storm's pretty legit too, though. Controlling weather is pretty powerful.
Yeah,
I feel
it's a
like.
big powerful thing.
If you can manifest tornadoes and hurricanes at will, that's pretty damn useful. I feel like.
Humans will never have that power.
Yeah, we don't need that. That's way too much power.
I don't think you could. There are these people that think you can unlock like,
Like Lucy.
That
Ancient-
movie with Scarlett Johansson,
yeah. I scoff at that movie because it's like
where she uses 100% of her brain. Ooh.
10%. What is that? Why is that trope still around? I think it's been.
Yeah, but
think
it
it's
just
been
gets
debunked.
repeated. People still repeat tropes. But I think it's been more debunked as time goes on.
Yeah, because I see I don't see as many young people say that anymore.
Yeah.
Because I remember when we were.
It was
younger.
our pre-internet generation. People would still say that, and I think it just carried over. But now in the internet, people know that it's a trope because as soon as anything comes out with
Yeah.
using your 10% of your brain,
No,
there's a
yeah.
slew of Twitter.
Yeah, because every time people would be like, "Yeah, we use 10% of our brains," I'm like, "You use 10% of your brain.
yeah,
I use 100% of my brain."
right. You just get shamed for it now. So
Yeah, I'm just like, do you know how much thinking happens in here? This is too much. I'm trying to shut it off. I'm trying to get to the 10%.
Right.
Actually, I wish I could.
that lead pill life.
Yeah.
They don't even know.
They don't even know. But it is kind of fascinating because what is the argument actually for that? The 10% thing.
It was just a guy, some scientist, probably some famous scientist, was saying someone took his quote. They they read it. They took the quote wrong because he was saying I think he was saying that humans on average use 10% of their brain at a time. Meaning, if you're doing a task where you're watching the TV or something, then you're using your visual center or something, or maybe your auditory centers. But he that's what he means. It's they're using 10% at a time or something of your focus or something. But then you still have all your other unconscious processes happening. So it's just a misquote.
Yeah.
Just you don't use 100% of your brain all the time, but you use 100% of your brain.
Yeah, I don't think the brain is even capable of that because you don't want to use 100% of your brain, right?
Why?
No, because you don't
at
have
the same time.
Your ego doesn't want. Your ego should never have control over your breathing apparatus or the machinations of breathing.
Well, I think even when he's saying you're using 10% of your brain, he's including the unconscious processes as well, probably.
Yeah, but I'm saying when people say you don't even use 10%, you only use 10% of your brain, they're ascribing some sense of your ego is using 10% of your brain. You know what I'm saying?
I'm not sure if that's true.
No, I think that's the argument they make. If you were
maybe
able,
so.
your conscious self was to be able to control
the unconscious processes, that's really bad.
That's a bad idea. That's what I'm saying. Yeah.
Imagine having to concentrate on breathing. That'd be fucking bad.
You fish out of water constantly.
Yeah.
Oh shit, I forgot to breathe.
Yeah, you would have no time to do anything else. Just think about breathing.
Hold on. I got to pump blood to my body. Yeah, you got to think about all these things.
Jesus,
Hold on, I'm passing.
That's hell. That's definitely hell.
Hold on, I'm passing. I'm filtering my bladder right now. Give me a sec.
I think that it is. I think some people do have that issue though.
What
where they have to think about breathing and things like that because, well, maybe not. I don't want to missay.
You're saying there's certain conditions that allow people.
Yeah, I think sleep apnea. There's a thing where you forget to breathe. I'm not entirely sure though. That could be just something where it's it's not you're forgetting to breathe. That it's just something else that's happening that's physical. But
right.
I'm sure there are some weird neurological issues where the unconscious parts of your brain
aren't working as they should or something?
Aren't working, so you have to control them consciously.
Gotcha.
I'm sure there is some kind of illness with that. But I won't speak more on that because I don't know shit about that.
True.
So.
Yeah, so please don't perpetuate this.
Yeah. Don't make us the new 10% of the brain trope.
No, that's a bad idea.
So.
But anyway, I guess it's it's an hour of us.
Good enough time, yeah. Seem real stupid in the beginning.
Yeah, but this is this is the thought process. No, this is this is the you get into the nitty gritty of it. You know what I'm saying?
Let us know if we seem too dumb in the beginning because
I think we
try to stay away from thinking too much on the podcast.
Yeah, we actually had a conversation too about why don't we talk about thinking topics more?
Yeah,
but then I was like, I'm
the
really
dead air would be fucking
I was like, I'm going to challenge ourselves today. But at least bringing up some of the stuff that we kind of think about off air, because somebody also asked me what do you do you guys really talk about physics all the time?
Yeah,
and I was like, I mean, inadvertently, it's not we're not doing this on purpose.
Yeah,
we just literally start questioning.
Right. But the physics we do on the podcast is very different from the physics we do in
offline.
Yeah, offline. The physics we do in offline is a bunch of writing shit down, messing up, thinking about it, pondering,
constantly refining,
arguing with each other about what makes sense. I don't think it would be very good. I don't think it would be a very good podcast.
Because it's a constant. But this is a good picture of this is what it's like. It's a constant refinement of ideas, and you get to a point where this makes the most sense. But even then, even like you're saying, the whole hypothesis with the cloud, I guess how lightning forms. This is still a hypothesis that you're not fully comfortable with. Yeah. So it's it needs more iterations, and even with the fire thing, I think that also there's more speculation there about what's happening.
A ton.
Yeah.
All those concepts are very, very untapped. If we were doing that in real life, we'd be spending a good 5 hours probably trying to figure this out. Especially if it's with math. Definitely.
Oh yeah. If you're trying to break it down to the chemical level.
Oh yeah.
Not even that. Just trying to figure out the basic, maybe classical physics.
Oh, gotcha. Yeah.
We're trying to think if we have to get involved density and things like that. Then we would be breaking it down much better.
Yeah, true.
But yeah,
But that's a good snapshot of like.
I wonder if people would be
what we
interested
do.
in seeing that. I always thought about that, where we would do a video of just us solving problems, but just completely unfiltered with just watching how we actually solve physics problems. I feel like it'd be interesting to see.
Yeah, but this is like a good intro. So if you thought this was kind of interesting, I guess how the thought process of it is, because this is very similar, right?
Yeah. Yeah, if you guys want to see us solve physics problems, I was thinking maybe we can do that for Patreon.
Yeah, true.
Have people see how they can see our unfiltered solving of physics.
Mm-hmm.
Because usually I would think that's maybe boring for an audience, but then I started thinking, you know what? I would probably enjoy that. Because
Yeah.
I'm the kind of person that likes to see all this weird,
Yeah.
unedited stuff where it's just like people are just doing things.
It's like you're the guy at the movie theater being like, "Get out of the room! Get out of the room!" And it's just like you're constantly
Talking to it.
Yeah, you're like, use Pythagorean theorem. Use Pythagorean theorem.
I'm the guy that definitely likes to see the DVD extras and things.
Yeah.
So
I like to see the behind the scenes stuff.
Yeah. So yeah, if you I guess that's kind of the prompt. I guess
Yeah.
if you do
Got a
like
couple.
more of the discussion,
Mm-hmm.
kind of seeing how our thought process goes, then
Yeah, maybe not for the normal podcast, but for maybe an extra like Patreon or something like that.
yeah,
Because we do need to get at it, because on the Patreon, I think we have one guy on there,
yeah.
a loyal fan. Shout out to you. You know who you are.
Oh yeah, for sure, dude. For real, shout out.
Yeah.
Actually, Terrence, dang, I forgot to get into this one thing that I kind of wanted. We have 10 minutes.
Okay. We can do it. We can do it real
We
quick.
can do it.
Yeah.
So
do
you
it real
got
quick.
in trouble this week.
Yeah. Getting a little controversy.
So do you want to clear the air a little bit?
Sure, we can.
Okay.
If anybody's watching now, it's just online. I got a little Twitter snafu, but to me, it's not anything real serious at all. It's actually, I kind of expected it a little bit.
So somebody called you racist.
Yeah.
Uh-huh.
I got called racist by a white woman. It was a great day in my life.
So what happened?
So it was basically, there's this whole controversy going on. I'm sure many people are aware in the science community of the 2 + 2 = 5 scenario, brought up by a physicist named Kareem. I forget his last name, but he's a pretty prominent Twitter personality. And also he goes to one of the Ivy Leagues. So he's a well-known kind of physics, or maybe he's I think he's a math guy, math stats guy. Not physics, sorry. And people went off, basically. It's been an ongoing thing for like the past couple weeks. And he got a bunch of racist comics and things and stuff in his DMs. And basically I just left a little tweet, a little morsel.
Reply.
Yeah, that said basically that if you're going to put yourself out here publicly, then this is the kind of stuff that you're going to accept, that you're going to have to accept. And of course, people then straw man.
So you were like, this comes with the territory.
Yes.
And they were like,
But then of course the straw man argument is that I'm saying that basically you should just roll over and take it, which I can get. That sounds like what it's saying. But for me, it's a different argument because, trolling is something I'm very familiar with. I was born in a troll. I would consider myself an ex-troll.
yeah.
I try not to be so much
Reformed.
these days, but yeah, a reformed troll. But I definitely understand the troll mindset to a high degree. And
So
for me,
trolling is characterized as behavior. Typically, it's tongue-in-cheek behavior, a constant like trickster mentality where
Yes.
you're antagonizing. You're
antagonizing.
antagonizing people,
Sure.
expecting a response to that that will rile them up.
yes, exactly.
Yeah.
The reaction is everything.
While
right?
you may not necessarily be, you're just saying something, knowing that it will cause them
to react in some
to
way.
react. Yeah.
And basically, what I'm saying with that tweet was basically saying that you are giving the troll what they want by putting that out there and showing that it's affecting you in such a way. Then you're basically just acknowledging that the troll got to you. And my statement was just along the lines of don't feed the troll, and of course people took that as just be a good boy or go along with racism.
Like
but
you're asking for it is kind of what they were saying.
Right.
But of course, for me, I have experience dealing with trolls, knowing the troll, living the way of the troll. I know that once you stop giving the troll attention, then it becomes boring. The troll is not interested in playing with people who aren't going to respond back or give reactions. It's not interesting. So that's all it was. And just if you want to call me a racist,
That's fine.
Yeah, so I mean, being a troll is not foreign to me either.
Yes.
I've caught into this troll thing. Although I troll for more stupid things. You know what I'm saying?
Yeah.
Like more low level things. In fact, I got in trouble recently on YouTube, of all places, because some guy said that it's a very popular video game. Some guy said that they programmed beard growth by testosterone in the video game.
Oh, yeah. I remember you
this?
telling me this one. Yeah.
The guy said that these amazing programmers programmed testosterone to give this guy, because the character has like beard growth throughout the game. And I'm like, there's no way these people programmed the hormone testosterone in the game. And I was like, it's a simple line of algorithm or code that just tells it to
But maybe he was just trolling.
No.
You don't think?
Because the response was sincere.
Oh,
and the responses that came afterwards. Because
I actually thought the programmers put
everybody,
testosterone in the game.
literally nobody was on my side. Like I was like, what? I was like, this is so asinine.
Yeah.
Just people. How many people agreed with him? Because there were too many thumbs up.
That's the interesting thing about the internet, because I know that my take is not that crazy of a take, but it's just that people love to bandwagon on the internet, right? And once you're on the bandwagon, that's just what goes, right? So that's why I'm not really even that upset about the tweet or why I even think it's wrong. I don't think it was a bad take. It's just that you see the surface level of it, and then you see the response that's a very easy kind of response, in my opinion. It doesn't really have... it's like these bite-sized things, right? So people just latch on to whatever is the main narrative or whatever satisfies whatever they believe.
Yeah.
So it makes sense.
Yeah, I mean,
it's like that's why you have to kind of untrain yourself with the internet. Just because you're getting hundreds or thousands of likes doesn't mean your take is good even. So
yeah, you're scribing. I mean, it also depends on like how the other person interprets your tweet, right? Because it may be
true.
This is not a good medium.
No, text never is.
Text is never like a good.
Well, not that short of text.
You remove so many dimensions of information.
Yeah,
like humans interact. At least in the most language, I think. Well, I wouldn't say most, but a good chunk of language is verbal.
Yes.
You know.
But honestly, I got to.
And nonverbal.
Yes.
Like visual cues and like understanding like what the other person, what their intentions are, because you could, if you said that in person, I guarantee you wouldn't have been the same.
But I got to say, I did kind of engineer that a little bit.
Okay. So you knew what you were doing.
I did know what I was doing, because I know that these bite-sized things are prone to that kind of stuff.
The ambiguity and stuff.
Yes, so you can kind of engineer. You can engineer responses from people. I knew I would get a response.
Yeah.
And, it's good to get... I am a clout chaser in some sense. Because I am trying to grow...
He's a rabble-rouser.
I am trying to grow the channel. I do like to grow, our stuff.
Yeah.
And, even negative attention can help you as long as you can curb it by showing people it's actually not negative. It's kind of like clickbait. I knew that tweet would be good clickbait.
Gotcha.
For someone to latch on to.
Yeah.
And it actually worked out even better. My favorite, because it was someone that was actually... who I respected and I actually follow.
Yeah.
And I was like, oh, okay, I can just... Yeah, they're not going to be able to deny my arguments because I'm going to have legitimate arguments.
Yeah.
So it's like you just got to get people interested in that one little click, and then if they can't resist, then bam.
Yeah,
you got to get that clout.
Dang.
So these things, but it's okay. I mean, it's like this is the internet, right? There's going to be... I've noticed that also with the internet, especially on things like Twitter, people cannot resist... they cannot resist responding to negative things. So even if your thing's not negative, as long as someone perceives it as negative, your things people tend to gravitate towards your stuff. So of course, I don't want to get us in the habit of putting out negative stuff, but if I can make something innocuous that might seem like it's negative, and then I can come back with a good, logical take, then that's fine with me.
Yeah.
I'm not going to get down to the line of going full like Candace Owens though, and just being a fucking shill for the right,
or like a Ben
like
Shapiro
that.
type guy.
Yeah, exactly.
It's like, he's
a full meme now, basically.
Yeah, the WAP thing.
Yeah.
We won't.
He's basically a showman now, full time.
We should do our own version of WAP. but call it
Like
weird.
our own rap.
Call it weird ass physics.
That's pretty good.
Just
But
our
would
own version.
be me and you in the video wearing risque clothes.
Yeah, risque. Yeah.
I don't think anybody wants to see that.
No. Unless you do, but
That's
that'll
not
be
for
extra.
the faint of heart.
Yeah. Yeah, but actually let us know. Forget everything we said before. If you want to see that WAP video, the WAP video version of us.
That would be funny though.
Yeah, that'd be great. But anyway, yeah, I guess that
Yeah.
concludes the show, and stick around for the outro.
Yellow.
Thank you
Oh, this is the
for making it this far. Outro. Thank you for
Are we
making
starting
it
with the outro?
I don't know. Thank you for making it this far, folks. And please like, comment, subscribe, share, and make sure to follow us on our socials.
Eigenbros.com, Eigenbros on Twitter, Eigenbros on Instagram, and Eigenbros2 on TikTok. Follow them all, guys. We got content everywhere.
Yes.
So,
And we'll see y'all later.
see ya.
Cool.